In this video, I want to look at a process that I refer to as undoing the baby chain rule. And to get started, I want to actually recall what the full-fledged version of the chain rule actually says. And the chain rule is a major differentiation rule that you learned in Calculus 1. And it says that if I want the derivative of f of g of x, that I have to find the derivative of f, but I evaluate it at g of x, and then I multiply that answer by g prime. Now, if the inside function g of x happens to be a linear function that looks like ax plus b, where a and b are real numbers, then the chain rule becomes the following statement. It says that d dx of f evaluated at ax plus b will be equal to f prime evaluated at the linear function times the slope of the linear function, because the derivative of a linear function is just the slope of that particular function. So this particular fact here is sometimes referred to as the baby chain rule. And we're going to look at some examples of the baby chain rule and then undoing them as integration facts. So let's look at the following example. Let's suppose I want to take the derivative of something like the sine of 5x plus 3. The baby chain rule says that this is going to be the derivative of the sine, which is the cosine, evaluated at the linear function, times the slope of the linear function, which of course would be a 5. So I've got this basic equation that says the derivative of the sine of 5x plus 3 is 5 times the cosine of 5x plus 3. So let me write that down in kind of a more compact fashion. Now, suppose I wanted to find an antiderivative for the cosine of 5x plus 3. Well, I want to kind of think in terms of the equation that we're looking at. I can divide both sides of this equation by 5. And when I do, obviously the right-hand side of this equation becomes the integrand that I am now looking at down here. But the left-hand side is really nothing more than the derivative of the sine of this stuff divided by 5. In other words, the derivative of cosine of 5x plus 3 should be the sine of 5x plus 3 divided by 5 plus any constant that I want to add. Well, let's check that fact. We can always check by doing a differentiation. So we will differentiate sine of 5x plus 3 divided by 5. Well, this 1/5 can come through my differentiation operator. And so this derivative here is 1/5 times the derivative of the sine of 5x plus 3. But the chain rule says that this particular derivative is going to be cosine of 5x plus 3 times a 5. And that 5 and that 5 cancel each other out, and I wind up with exactly the integrand that I started with. So this stuff here says that this particular formula is correct. Now, what I really want to do is I want to kind of think about what did we really do here. What we really did here is we said that we're looking at an antiderivative of cosine, and the antiderivative of cosine, of course, is sine. But we didn't look at sine of x. We plugged the linear function in, and then we had to divide by the slope of it. So in other words, what I can do is I can wind up creating a formula. So this is the process for undoing the baby chain rule. The first thing that is, I'm going to establish some notation. I'm going to let the antiderivative of little f of x be capital F of x, plus, of course, whatever constant you want to add. Then what I can say is this. The antiderivative of little f evaluated at ax plus b is going to be equal to capital F evaluated at ax plus b divide by the slope of ax plus b, which means divide by a, and then add any constant that you want to add. And the reason this works is that if I differentiate my answer over here, if I differentiate capital F evaluated at ax plus b divided by a plus that constant, this is what we get. Well, first of all, I can break a derivative up at that plus sign. So I'm going to get d dx of capital F of ax plus b divided by a plus d dx of that c. And that's just going to be a big fat 0. So this here is a big fat 0. Now, d dx of something divided by a, that something divided by a comes out of the differentiation operator. And so I'm left with 1 over a times d dx of capital F evaluated at ax plus b. But now I'm in a situation where I can use the chain rule, and when I do, I get 1 over a times, this derivative is going to be capital F prime evaluated at ax plus b times the derivative of ax plus b, which is just an a. Now, this a here and that a there cancel out, and so I'm now left with capital F prime at ax plus b. But this evaluates to little f at ax plus b, since capital F prime is known to be equal to little f and that means capital F prime evaluated at ax plus b is going to be little f evaluated at ax plus b. So to finish up, I want to do an example using this process of undoing the baby chain rule. So let's look at this example. Suppose I want to find the antiderivative of something like secant squared of 3x minus 2. Well, I know that the antiderivative of secant is just tangent, because the derivative of tangent is equal to secant squared. So using that fact, I can say that this particular integral is going to go back to the tangent evaluated at 3x minus 2, but then I have to divide by the slope of 3x minus 2, and then I add the constant at the tail end. My check would go like this. If I take the derivative of tangent of 3x minus 2 divided by 3, that's going to be 1/3 times the derivative of the tangent of 3x minus 2. And when I look at that, I'm going to get 1/3 times secant squared evaluated 3x minus 2 times the slope of 3x minus 2, which is just a 3, and This 3 and this 3 are going to cancel each other out, leaving me with the integrand that I started with. And so I know that my answer was indeed correct.